Welcome. This question says a current of 9 amps flows along the segment of wire that is shown in the diagram. So let's look at the diagram. We have a X and Y plane, and we have a piece of wire shown in black, and there's a current, that's the I, flowing along it. The magnetic field is uniform and has a magnitude of 12 Tesla. So this piece of wire is in a magnetic field, uniform magnetic field, and we're showing this as this symbol which represents the fact that it is going into the page, and it's got a symbol B on it, meaning magnetic field. And that's 12 Teslas. What is the vector force? What vector force is experienced by the wire shown in the diagram? So I need a principle, and my principle is that my vector force is equal to the current L crossed with B, and the current is the current, so we know the current is 9 amps. The L, the definition of L is that it is a vector which goes from the beginning of the wire to the end of the wire in the direction of the current flow. So in this example, my vector L is a line which goes from this point at the beginning of the wire to that point at the end of the wire. It is not dependent upon the path taken. It's, if you like, the displacement vector from the beginning of the wire to the end of the wire in the direction that the current passes, and the current in this case passes from the point on the left to the point on the right. So I can say, oh, then my vector L is equal to, and I look at my diagram, and it's going to be 6 minus 2, which is plus 4i. And then I look and I say there's no y-axis displacement, plus 0j, and there's no z-axis displacement, 0k meters. So I drew it, and I decided which direction to put the arrow, and then I looked at my axes, my x-axis, my y-axis, and by implication my z-axis coming out of the paper. And I recognized the fact that it was a length of 4 meters that only had an x component. That's one of them. What about this B? So the B, if I look at my diagram, my B is basically going into the page. I only showed one symbol. I could have put these symbols all over the place, and there is no significance to where I draw them. It is just the fact that they are on the page. And there are 2 symbols I'd like you to get used to. One is this, and the other one is that. And the kind of schema is that you have an arrow with tail feathers. And if the arrow is coming towards you, there's your eyeball, you see the tip with a circle around it. So that's coming towards. And if you look from this direction, when it's going away from you, then you see the tail feathers leaving. So it's going away. So I look down here and I see that this symbol is going away from us. So our B is only in the z-axis, and it has no component in the x-axis, so 0i. It has no component in the y-axis, so 0j. And it only has a component in the z-axis, and that is 12 Tesla. But it's going away. It's a negative, plus negative 12 Tesla. And I suppose I have to invoke for that the way we do our coordinates in physics. The way we do our axes in physics is we have x, we have y, and then the positive z comes out of the page towards you. So when something is going into the page, it's negative z. So an awful lot of this question is simply about interpretation of the diagram. So I say, let's do a I, J, K. And remember, with a cross product, the order matters. So I want to put my L down first. So that's 4, 0, 0. And then I want to put down my, so that's L. And then I want to put down my B. And my B is going to be 0, 0, minus 12. And then I do my cross product, and remember what we do, we cover over the X column, the I column, and I say, okay, well, we have cross multiply 0 minus 0, which is 0i. And then I put a negative down, and I turn my attention from the I column, and I turn my attention to the J column. And I cross multiply, and I go minus 48 minus 0. So that is minus 48 J. Now I already had the negative operator there, so I'm going to have two minuses. And then I put down a positive sign for the K term. And I change my focus. I put my thumb, I'm showing highlighted, but if it was in real life, I'd put my thumb over that column because I don't want to mess with whatever column I'm looking at. I don't want to mess with those numbers. And I have 0 minus 0, which is 0k. Now I'm running out of space, aren't I? So I'm going to do that. So this comes up here, and I say, oh, L cross B is equal to 0i minus and minus makes plus 48j plus 0k. But I want I L cross B. So I'm going to say, well, I L cross B is just going to be whatever I is multiplied by it. And I is 9 amps. So I have 0i plus. If it was 10, it would be 480, but it's 9, so it's not 480, it's not 440, it's 432. So 432J plus 0K. Aha! So let's write down my answer with units. So FB is equal to 0i plus 432J plus 0K. And of course it's a force, so that's going to be newtons. And there I have my answer. So this question involved being able to interpret the diagram along with the text, and then it involved understanding the true definition of L, which is it's from the beginning of the wire to the end of the wire, a straight line in the direction that the current flows, and I had to be able to make up that vector. And then I had to be able to look at this symbol for the magnetic field and interpret it as meaning that the magnetic field was going into the paper, which means the negative z-axis. So I had to understand my axes, orientations. And then having done that, I had to remember my equation and do a cross product. So there's a number of things involved there, but it's a nice question. So there we have it.